ever wondered how your favorite app, just works during a huge event, like a new product drop or a massive online sale? Well, behind that smooth experience, there's a constant, raging battle against a tidal wave of user traffic. So today, we're going to pull back the curtain and look at the brilliant systems that keep our digital world from completely falling apart.
See, modern apps aren't really a single thing anymore. They're more like these sprawling digital cities, just like what you're seeing here. Every one of these little connected parts is its own specialized district, right? You've got one for logins, another for your shopping cart, one for payments. This whole setup, this microservice architecture, is incredibly powerful. But you can imagine, trying to manage the traffic in a city this complicated is a massive headache.
So that brings us to the real question, right? When millions of us are all trying to do the exact same thing at the exact same time, I'm talking midnight on New Year's Eve, what's the magic that stops this entire digital city from just grinding to a halt?
To get that answer, we really have to understand the unique kind of traffic jams these modern apps get into. This isn't just one simple highway. It's this complex web of digital streets, where a single fender bender in one little service can cause a citywide catastrophic pileup.
So at its core, the whole idea of microservices is to break up one giant application into a bunch of these smaller, independent services. It's great because it lets teams innovate faster and scale up specific parts, but the trade-off? It's complexity. Instead of one front door, you suddenly have hundreds, and every single one needs its own traffic cop.
For a long time, the way we managed all this traffic was, well, it was simple, but it was way too rigid. And as you're about to see, you just can't bring old-school, inflexible rules to a brand-new, high-stakes game like this.
The old way is something called static rate limiting. Just imagine a bouncer at a club who has one and only one rule: 100 people per minute. That's it. No exceptions. It doesn't matter if the club is totally empty or if there's a huge line outside. The rule is the rule. Simple? For sure. Smart? Meh, not really.
And this slide just perfectly lays out that mismatch. On one side, you have the brick wall of a static fixed limit, and on the other, you have the chaotic, stormy reality of real-world traffic. A static limit is a blunt instrument, right? It totally ignores how the system is actually feeling, and it's a one-size-fits-all approach that just completely fails when things get dynamic and unpredictable, which, on the internet, is all the time.
So what engineers needed was a much smarter bouncer, one that could actually check how crowded the club is, see who's in the VIP line, and adjust the flow of people in real time. Basically, they needed a system that could learn.
And that's where adaptive rate limiting comes in. Instead of just a fixed number, this system acts more like a doctor, constantly monitoring the application's vital signs. Things like its CPU usage, its memory, the length of the line of requests waiting to get in. And based on that live data, it's always adjusting the traffic flow, turning the dial up or down as needed to keep the whole system healthy. The whole idea boils down to this really simple but incredibly powerful feedback loop. First, it's always monitoring the system's health. Second, it's analyzing that data, constantly asking, are we okay? Are we getting stressed out? And finally, based on the answer, it adjusts the traffic. It either opens the gates a little wider or eases off the gas to prevent things from breaking. It's this continuous, intelligent dance between what the system can handle and what users are demanding.
And this is where it gets really cool. You can add machine learning to the mix, and these systems can start to see patterns in all that data. They learn to recognize the signs that a huge traffic surge is about to happen. Maybe it's lunchtime on a Friday, or a big game is about to end. And this lets the system prepare and adjust its limits before the flood of traffic even arrives. That's a total game changer, moving from just reacting to problems to actually getting ahead of them.
Okay, so this all sounds great in theory, but let's make it real. Let's look at a massive, real-world case study. We're going to talk about the food delivery giant Zomato and how they tackled a data problem that was just at a mind-boggling scale.
We're going to zero in on their billing platform. And look, this isn't some minor feature. This is the absolute mission-critical heart of their whole operation. It's the system that handles all the money, paying out millions of restaurants, millions of delivery partners. If this thing slows down, or even worse, fails, the entire business is in trouble.
And just get a load of the numbers they were dealing with. 10 million financial events every single day. Their database was trying to manage billions of rows of data. To even keep their head above water, they had scaled their database out to 25 separate machines. But even with all that power, the system was just buckling during peak hours, lunchtime, dinner time, and it was causing these awful, unacceptable delays. So they knew their old, rigid system just couldn't cut it anymore.
They needed something new, something that wasn't just powerful, but was also resilient and, you guessed it, adaptive. It was time for a really big switch.
So what Zomato did was pretty radical. They completely changed their architecture. They moved away from a traditional database that they had to manage themselves, called TDB, over to a fully managed serverless database, Amazon DynamoDB. Now, serverless here just means they didn't have to worry about managing the actual computers anymore. The system just automatically gave them the resources they needed exactly when they needed them. This is a huge fundamental change in how they thought about their infrastructure.
Okay, so the old design was a classic database. Think of it like a library where all the information about a single order is scattered across a dozen different books. To get the whole picture, the system had to run around, find pages from all those different books and piece them together. Super slow when you're doing it millions of times. The new design is just so much smarter. All the info for one order is in one spot. One quick read, and boom, you have everything. Plus, it scales automatically. It just adapts to traffic spikes without anyone having to lift a finger.
So they make this huge, complicated change. What was the payoff? Well, honestly, the results were nothing short of astonishing.
First up, speed. The average time it took their system to answer a request, it dropped by 90%. Let that sink in. A 90% decrease. That is the difference between an app feeling sluggish and broken and one that feels totally uninstant.
Next up, capacity. The new system could handle 4 times the amount of traffic as the old one. 4x. They didn't just fix their slowdowns, they built a system that was ready for massive growth in the future without even breaking a sweat.
And here's the real kicker. This brand new system wasn't just way faster and way more powerful. It was also 50% cheaper to run, half the cost. And why? Because they stopped paying for a bunch of computers to just sit around doing nothing during quiet hours. The new adaptive system meant they only paid for exactly what they used, from one moment to the next.
And don't just take my word for it. As Zomato's own engineering team put it, this wasn't just a win for the techies. It had a huge business impact. It meant less lag, it meant faster payments to all their restaurant partners, and it meant better, more reliable service for absolutely everyone. It literally made their entire business ecosystem healthier.
So all of this kind of brings us back to the big picture, doesn't it? Our world is getting more and more unpredictable every day. The lesson here from Zomato and from these adaptive systems is crystal clear. Rigidity is just another word for fragility. The systems that are actually going to survive and thrive in the future are the ones built not just to be strong, but to be intelligent, responsive, and most important of all, built to adapt.